Yeah. So let me tell you the agenda for today. Then we'll go ahead. We were discussing about embeddings yesterday. Still, we have somewhat a discussion related to embeddings, and I will take you to discussion on RAG. But before that, first what I will do is I'll complete the prompting techniques. Few more prompting techniques are there. We'll discuss about those few prompting techniques, and then we'll complete this prompt engineering today. And then again, quickly, I will do a revision on embeddings. Then we will discuss about RAG, what is retrieval augmentation generation. And after you understand about RAG, to develop agents, we'll understand that we need to do a lot of coding. We'll see how to use a framework called as LangChain. What is LangChain and why LangChain? We'll understand today. So that is the agenda. And if possible, if time permits, we'll do a simple application using LangChain. So that is a plan for today. Let us see how it goes. Let us start with prompting techniques. Yesterday, I have actually uh, discussed about React React prompting, right? Yeah. So the next thing today is generate knowledge prompting. A very good prompting technique. Let us see what it says. What is generate knowledge prompting? It is a technique to prompt a model to first gather the relevant information and then synthesize a detailed response. So the idea is if you are directly asking the model a question, it might immediately give an answer. It might be wrong or it might be correct. But the idea is you can say to LLM, hey, first, before you give the response, try to gather the relevant information first. Then only give the response. So if you give a prompt in such a way, most probably you'll get right answer, right? That is the idea in this generate knowledge prompting. So what is the standard structure of this prompt? You have to give a few short example to actually tell the LLM how it has to generate the knowledge. So what you have to do, you have to follow this pattern: question, gather knowledge, and then answer. This is the pattern you should follow. Let me give you an example. I will go to ChatGPT. Yeah, I will write my prompt. Let me open my notepad. Yep. So let me give you a very good example, which I have. Yes. So this is the example which I have. Maybe it is a little bit more bigger, but it is good. So I'm giving a few short example. Question: what is the time complexity of quicksort algorithm? I'm giving again generated knowledge. It gathered the knowledge about quicksort algorithm. Then answer. Average time complexity of quicksort is this much. Again, one more example. What are key differences between REST and GraphQL? The generated knowledge about REST and GraphQL, and then the final answer. Then I am actually asking about what are the advantages of using TypeScript over JavaScript. Then it has to follow the same pattern, right? First, it has to gather the knowledge and then synthesize the final response. This is the example of how to tell your model to generate the response. First, gathering and then generate. Let me just see. So it is generating the knowledge about TypeScript and JavaScript. It gathered all this information, and then based on that, it is giving the answer. TypeScript offers advantages over JavaScript, etc. So this is an example. So the idea is, see, if you directly ask this question, what are the advantages of TypeScript over JavaScript? You may get the answer, but you may not get elaborated or correct answer. So what are you trying to tell is first gather the knowledge and then only give me the response. So we'll get better responses. That is the idea of gathered generate knowledge prompting. Very simple prompting technique, but very useful. So it's a combination of uh, few short prompt. It's also using few short prompt. Fine. Let us now talk about one more very interesting prompting technique called as self-consistency prompting technique. What is this self-consistency? Yeah, self-consistency is a technique which enhances reliability by generating multiple outputs for same prompt and choosing the most consistent answer. Okay. So for same query, it will generate multiple outputs and then it will choose the most consistent answer. Oh, confusing, right? It will be good if you can see with an example. So let me just give a prompt. Yep, here is prompt. Is the movie The Dark Knight appropriate for an 8-year-old child? Answer with only yes or no first. Then explain in one sentence. Okay. Generate 5 variations by adding different contexts or perspectives. Okay. And here I'll add at the last. These are different perspectives as a child psychologist, as a parent of young children, having worked in movie ratings. So these are the 5 contexts. Generate 5 variations by adding different contexts or perspectives. Each variation should give a yes or no, followed by a reasoning. Final recommendation would be based on the majority consensus. Okay. So I can actually write Llama 4, remember. Yeah. I'll also write as a mature citizen person. Okay. Let us see. I generate 6 variations. Yeah, let us see. I will use this prompt. Yes. Okay. Final recommendation is no. Majority of consensus, 6 out of 6 say no. Here are the various perspectives. As a child psychologist, the answer is no. Is a movie Dark Knight appropriate for 8-year-old children? All of them voted no. So final recommendation is no, it is saying. As a child psychologist, no. As a parent of young children, no. Having worked with movie ratings, all these perspectives, it is getting no. So it is possible that for your query, some may say yes, some may say no from different context or perspective, but majority will be taken to give you the final recommendation. So this is an example for self-consistency. In the answers, whatever answer is mostly consistent, that will be chosen. Okay. Okay. So let us go ahead. The next important prompting technique is tree of thoughts. It is a little bit confusing one, but I'll try to put it in a simple way. What is
Sambar rice with liver.
Yeah, sorry, I think you can move. You can go on mute, all of you. Yeah. So what is this tree of thoughts? Let us see. Tree of thoughts is a structured reasoning approach. It models the decision making as a tree structure. Each node represents a possible solution path. The TOT framework evaluates multiple thought paths to arrive at the most effective solution. So when for every problem there can be multiple solutions, right? This TOT, it models the decision making as a tree structure. Each node represents a possible solution path. This TOT framework evaluates multiple thought paths to arrive at the most effective solution. It encourages exploring multiple reasoning paths before arriving at a final answer. It allows complex problem solving by breaking down the question. Okay, it's not understood by just going through these sentences, right? So let me tell you, elaborate step by step how this tree of thoughts works. Start with a prompt and generate initial thoughts based on a prompt. It has to generate multiple thoughts for the same question. Expand each thought into sub thoughts, forming a tree. And then evaluate each path to decide which one to continue exploring. Then reach a final thought based on the most promising path. Okay, these are the steps. Maybe you will actually see, you'll actually see if you understand this diagram. You can understand using this diagram. See, for a given input question, first we have to generate multiple thoughts. Then for each thought, you can generate multiple sub thoughts. Then evaluate each sub thought and then finally arrive at one final thought. So for one prompt, you are generating multiple thoughts. And for each thought, you are actually going through again multiple sub thoughts. Then among all the sub thoughts, you are selecting one. So like that, you go on and select one final best thought, right? Maybe again it is confusing. Let us see with an example. So let me just tell you with an example. If you see this example, you'll understand. Just a minute. Yes. This is a problem. This is the prompt. Let us see. I'll explain you. You'll understand it clearly. I have a programming problem. Given a string of parentheses like this, determine if the parentheses are balanced. That means every open parenthesis has a closing parenthesis. Is this string of parentheses balanced? No, right? There are only two open parentheses, but three closed parentheses. So it is not balanced. So I want to find whether this string of parentheses is balanced or not. This is my problem statement. Now I'm telling, follow a tree of thoughts approach to solve this. First, generate three possible methods to check if the parentheses are balanced. Briefly describe each method. Then evaluate each method based on simplicity, accuracy, efficiency, especially for handling edge cases, etc. Then what? Then I'm saying choose the best approach based on this evaluation and provide a detailed step-by-step explanation of implementation for selected solution. So give the final answer whether the string is balanced using this approach and explain why this method is optimal. See, I am asking it to first generate three possible thoughts. For solving this problem, first generate three possible methods or thoughts to check and briefly describe about each method or thought. Evaluate each thought or method based on these parameters. Then choose the best approach, right? So let us see if I give this prompt, let us see what will happen. Step one, what is it doing? It is generating multiple thought paths. First method is stack-based approach. So you want to find whether this parenthesis is balanced or not, right? The idea is push every parenthesis onto a stack, open parenthesis. Whenever a closed parenthesis is encountered, pop from the stack. If the stack is empty when trying to pop, it is unbalanced. At the end, stack should be empty. So this is first method is stack-based approach. Good. And another method it is saying counter-based approach. That means whenever it sees a open parenthesis, increase the count. And whenever it sees closing parenthesis, decrease the count. So finally, the count has to be 0. And like that, third method. Then this is all first step. It generated three paths, three thoughts. Then second step is evaluating each method based on simplicity, accuracy, efficiency, and handling edge cases. Right? So among all, it selected method 2, the method 2, which is counter based, is most optimal, simple, and time complexity is this much. Then step 3 is saying implement the best approach. That means counter method. And it's giving me the code for this final. So final answer, it is saying string is not balanced. And it is explaining why this method is optimal. So it generated multiple sub thoughts, and for each thought, it generated sub thoughts. It evaluated thoughts and then finally found the best thought and gave the final answer. Right. This is called as TOT, tree of thoughts. Right. So the same thing. So that's about tree of thoughts. Now, the next one is reflection prompting, a very interesting prompting. It's a technique that encourages the model to think critically about responses. So the purpose is to improve the quality and relevance of AI generated content. Okay, so before you give the response, I want the model, before it gives the response, I want the model to first of all critically think whether this response is appropriate or not. Right. So let me just tell you a simple example. What I can do is I can write a prompt like this. Write a short story. This is a task actually. Normally people, what they do, if this is a task, writing a short story, people will write this prompt, write a short story about dragon. But instead, if you want to use reflection prompting, before it gives the story, you can tell the LLM, hey, reflect on these questions before giving me the final answer. So this is the basic prompt without using reflection technique. But if you are using reflection technique, this is how you should write. Write a short story about dragon. Before writing the story, reflect on this. Consider what kind of dragon is it? What is the motivation of the story? Who are the characters? What is the setting? So you are telling, okay, before you write the story, before you give me the response, reflect on these questions. So whatever you have in your mind, you have to tell, then you will get the better answer. So the response, whatever you are getting in this case, will contain answers for all this, right? To reflect. So that is how you can use a reflection prompting technique. Okay. So these are the techniques. So what I will do is, um, we understood prompting, most of the prompting techniques. I have a notebook where I have created all this prompts. I have written all these prompts in a notebook. This is the notebook, prompt engineering notebook, where I have given you step-by-step instructions on how to use each technique, whatever I have discussed. And this is available in the Google Drive, whatever I shared. For each and every technique, I have given the example. You can go through it and complete it. What I will do is, okay, right now I have learned various techniques, but for a given task, which technique to use? That might be the question, right? So what I will do is, later, maybe tomorrow or day after, I will give you multiple prompts. Then ask, okay, which prompting technique do you choose for this kind of task? So you can think about whatever I have discussed, and then you can give me the answers, right? So today we'll just complete this prompt engineering. Later again, I'll come back with different tasks, and then we'll do a simple exercise on what prompting technique is better for this, and how to write the prompts. We'll see, right? So that's what I want to talk about, prompt engineering. Very simple. Actually, to say there are a lot of prompt engineering techniques. These are the important things which we see regularly. I have covered them. Okay. So once we are done, let us go back to embeddings. So quickly, I will revise the topic of embeddings, and then I want you to understand clearly about RAG. Then I'll take you to LangChain. So yesterday we understood, if I have two multiple texts, let's say I have two texts. Yesterday I gave you an example, bright day and sunny day. I want to find whether these sentences, it might be a sentence or a word, whatever. If my task is to find whether these two sentences are similar or not. If they're similar, what is their similarity score? Whether they are 80% similar or 70% similar or 10% similar. Then what we have to do, we have to convert this string to an array of numbers. Okay. These numbers should be between -1 to 1. So that whenever we try to plot this and try to draw a line, there will be a theta or the angle between the lines. So if you find cos theta, this can give you the similarity score. If cos theta is 0.95, I can say that these points which are plotted are 95% similar. This concept is called as cosine similarity. Okay. Now the question might be, how do you convert this string into an array? This array should contain some numbers, right? Let's say 0.86, 0.32, 0.1, like that. Each number in this array will be a score about something. What this sentence is talking about. Is this sentence talking about politics? Maybe there can be one number minus 0.9, which says minus means let's assume that this number at fourth index, it identifies whether this sentence is talking about politics. No, it is not talking about politics. So the score is negative 0.9. So actually, each number in this array will try, it can be, we can think like each number actually gives some score for some topic. Like this might be a score of whether this text is talking about ice creams. This might be a score of whether the text is talking about some food item, whatever. So somehow we have to convert this string to array of numbers. Each number should represent some score for a particular topic. Maybe it can be politics, it can be education, whatever. It can be about weather, right? So these numbers. That means the numbers in this array is a score for some specific topic. Maybe this might be a score for whether this text is talking about politics. This might be a score for whether the text is talking about weather, right? Or so. So this array of numbers, I can say that they are having some embedded meaning, embedded scores for various topics. So I can say that these array of numbers are nothing but embedding for this given text. They embed the semantic meaning of this given text. So now, how do you generate an embedding for a given text? Again, there are embedding models which are created. Just like LLMs, there are embedding models. They have been trained with huge amounts of data so that if I give any string, it will automatically give me the array of numbers. It is a trained model. During training phase, they might have given, okay, these are two strings and this is the expected array. Like that, they might have trained. We don't bother about how the training is done. If I give my string to this embedding model, it will give me an array, right? So what is the purpose of embeddings? As I told you, embeddings are useful to find similarity score. If you have two embeddings, what we can do? We can plot them on the graph and we can find the cosine value. The cosine value will give you the cosine similarity, which will tell how similar are these two vectors. Right. That is the purpose of embedding. Now, practically, where are these embeddings used? I'll tell you a practical scenario. Now let us concentrate on this interesting thing. I know a website called as chatpdf.com. Very good website to demonstrate the concept. What we can do is we can upload any PDF file and ask questions related to that PDF. Let me do that first. Okay, I think already there is one PDF which I uploaded because I logged in. Once I logged in, it is automatically detecting what PDF I have uploaded. I'll just select this and delete this. Yeah. So now I have logged in already with my account. I can chat with any PDF. Let me first show you how this is working. Then we'll go into a concept of embeddings, how this website is working. I will explain you clearly. So I have some documents. Okay. I have some document. I have a book PDF called as Employee Handbook. if I open this, this is a PDF, which is an employee handbook for small business. Whenever a new employee joins in this company, they will give this employee handbook. Here it contains some rules, employee related policies. What are their workplace commitments? What are companies' policies like dress code, code of professional conduct, all these attendance policies, leave policies, all these policies are related to employees. Now, what I want to do is I wanted to upload this employee handbook and ask questions related to this employee handbook. Okay. So what I will do is I can just drag and drop this employee handbook here. It'll upload. So it is uploading. This website has read this book and now it is asking, you can ask questions, right? Now I'll ask a question. Tell me about leave policies. What are the leave policies? Just give me the policy names. That's all. Oh, let us see. These are the various leave policies, vacation leave, sick leave, blah, blah, blah. And it is giving in section 6.1, 6.2, etc. And also it is if I click on these links, 20. Yep. See, here is the link to see what all are the policies in section 6, vacation policy. It is referencing to the pages as well. Right. So what I'm able to do is I'm able to chat and get answers only from this PDF. But what if I ask some information which is not in this PDF? Let me check. Tell me about Donald Trump. He is actually making news nowadays, right? Because of all his policies. Tell me about Donald Trump in 5 sentences. Let us see whether it will give about the information. Yeah, it is giving about Donald Trump. That information is definitely not present in employee handbook, but this chart PDF is giving. So by default, it will also give the response from the LLM, not only based on the uploaded one. You want to ground the responses of this chat PDF to only the information presented. So you have to ask it clearly. So what I can do is answer the below question only based on data present in the document. If you can't answer the question from the information present in document, reply with I don't know. Okay, now the question is, tell me about Elon Musk in 1 sentence. Let us see. I don't know. It is simply saying. So it is up to you. You have to prompt it correctly. I said you have to answer only based on the data present in the document. That means you are grounding the responses only to this, right? Now, if I'm using the same thing in chat, if I'm using the same thing in playground, can I give this as a system information, system message? Yes, this is a common message, right? This I could give as a system message and this is a user message. Fine. Now you understood how this is answering. If I have to implement something similar to chat PDF, how would I do? And how embeddings will help me in this case? Let me discuss about it. Okay. Very interesting discussion. So please listen here. Yesterday also I gave an idea, but today you'll get more clarity. Let's assume that this is my PDF document. I'll tell you what all are the steps. This is containing, let us say, 100 pages. Now, by using some library, I might have to load this PDF and read the text in this PDF. So I might need to use something like a document loader, maybe a library, to load this document, load this PDF. And this document loader, there are some predefined libraries also. What they will do is, for each page, they'll create an object called as document. For each page, a document object will be created. And document will contain text and also something called as metadata. That means the information about this text. Maybe this text is from page number 7. The metadata will contain what is a page number and from which PDF. All such information can be present in this metadata. So normally these document loaders, what they do is they read this PDF and for each page, document will be created. The text will be the page text and metadata will contain some information like what is a page number from which this text is coming, in from which PDF it is coming, etc. How many tokens are there, etc. Okay. So I have two options right now. One is I'll take the first option. First, let us complete this option. Then we'll discuss some problems as well. So what I need to do is I need to store these documents in a database. I don't want it in an SQL database. I wanted this to be stored in a database which can support similarity search. So such databases are nothing but vector databases. Why we are calling them as vectors? Because these embeddings, this array of numbers, once we plot on the graph, we can draw a line with the direction, right? This array also can be termed as a vector. So any database which supports storing vectors, and then once we have vectors in database, what is the purpose of this? To do similarity search. So any database which supports storing vectors and allows to do similarity search based on those vectors is a vector database. There are a lot of vector databases. The popular ones are ChromaDB, a simple lightweight database. FAISS, FAISS. This is nothing but Facebook AI similarity search, FAISSDB, Pinecone. Like that, there are a lot of things like Post PG Vector database. I will list you a lot of vector databases. There are a lot of vector databases. For our clarity, just I'll take one database as an example and I will base all my discussion on this. We'll use Chroma as a vector database. Assume that this is Chroma. Chroma is internally using SQLite database by default. It is internally using. Okay. So now what we have to do is once I use a document loader to load this PDF, I'll get an array of documents. For each page, it will create this document object. And as there are 100 pages, I'll get an array of 100. Then what we have to do is for each document which is having text, we have to use some embedding model and convert this, generate the embedding for the given text. Okay. As I said, embedding models, these are also models which have been trained, right? Suppose if I'm using OpenAI embedding model, there is something like text starting with ADA, something like this. Text embedding ADA, something like this. Let's assume that we're using any model. We can use any model to convert this text or create embedding out of this text. Then what we do is in vector database, we store the data, the document along with embedding. Maybe you can visualize like this. This is not exactly. Maybe you'll have a table which has embedding and also text and metadata like that. Right now I'm showing as a single table. Maybe this can be in multiple tables, whatever. Okay. So somehow what we have to do for each document text, we have to create embedding and then we store it. Okay. So the text is containing the whole text of this page. One document right now points to one page of the PDF. Okay, fine. We've stored our data, PDF data in database. Hey, one thing I want you to understand, this PDF, is it containing structured data? No, the PDF will contain unstructured data. What do I mean by structured data, unstructured data? Normally in SQL databases, you will store data in SQL database. For example, there's a users table. Users table has some columns. You store the data about users in user database table, right? The users will have a structure, a data structure. A user may have user ID, first name, last name, etc. So if you are storing data in something like SQL databases, that means you are having a structured data. But in this case of PDF, the data present in PDF is not structured, it is text, right? It is unstructured data. So that unstructured data I actually stored in vector database. Okay, this is first part. Storing is first part, stored. Now let us take to the next step. This is my database, which is already having the data. Now this is my application, my code. And this is the LLM. Now let us see. Let's assume that this is chatpdf.com. Application. It's a web application, right? Whenever user chats and sends a text, then what my application has to do? It has search, first of all, for similar documents. Okay, let us take another approach. Let's assume that I'm asking what are leave policies of my organization. Let's assume I'll replace my organization with my company name. Now, if I send this question to my app, if my app is asking the same question, sending a prompt to LLM and asking the same question, will the LLM know about the leave policies of my organization? No. So LLM might say that I don't know, or it might give wrong information also. So LLM does not know about our own data. This our own data is in our database. LLM does not know. So what should be our approach in this case? So now, in prompting techniques, you have understood whenever you are sending a question to the LLM, you can also provide a relevant context also and ask, hey, LLM, answer this question only based on the provided context text. Then LLM will try to answer this question based on the provided context, right? This we have seen in question answering prompt. Now, the thing is, whenever we get this message, what are the leave policies to our app? My app has to first find the context from the vector database. it has to search the vector database for any documents talking about leave policies. So what my application can do is, for this text, it will create an embedding. For our actual query, an embedding will be created. Then my application can do a similarity search on the vector database. Every vector database will provide its own API for doing the similarity search. So my application can use this API and do a similarity search. As I told you yesterday also, what is similarity search? For this embedding, it will iterate over all embeddings in the database and will find similar documents. That means maybe I can say, I want top 5 documents. Whenever my application is querying the vector database, I can ask for top 5 documents. So the vector database will do a similarity search and find top 5 documents whose embeddings are having highest similarity score for this embedding. So my app will get top 5 documents. Now this top 5 documents should be added as a context to my original question and then sent to LLM. Then LLM will be able to generate the response based on the given context. So here, what are we doing? We are retrieving the information from vector database. We are retrieving the similar documents. We are doing a similarity search and then augmenting that retrieved documents as a context. Then we are sending this to LLM and LLM is generating this response. So basically here in this case, we are doing RAG, retrieval augmentation generation. So by using embeddings, I guess how you understood how this vector databases work and how we can do RAG. Yeah, let me know if you have any questions till this point. Then I'll take this discussion further. Any queries? Yes, Nikhil, tell me.
So, Shiva, I guess then this chat PDF, the example that you gave, that is not an agentic application because as per your discussion or as per our discussion in the previous sessions, an agentic application doesn't know how to use it um, rules, right? But here your app knows how to do similarity search and other things. In the agentic app, I was sending the information towards the LLM that I have a vector database. Help me how to fetch information from that. But in this case, your app is well versed with how to perform or how to uh, convert the input into an embedding and then pass that embedding into the vector API. So in this case, that the difference between this app and the agentic app is that this will first directly make an interaction with the tool or the software. Then it will take the response and send it to LLM to perform in a formatted way. But in the agentic app, it will ask the LLM that you tell me how to interact with the software. Is it Mrs. Understanding right here?
Correct. Yeah, whatever you said is correct. So in this, as you said, okay, let me explain to all of them. In a normal agent, what is normal flow? Agent will have tools.
Yes.
In this case, my vector database, for reading this vector database, let us say my agent has a vector DB tool.
Yeah.
It knows this tool. By using this tool,
Mm-hmm.
it can retrieve the data from the vector database. There can be a vector database tool. Normally,
Okay.
what you are saying is, whenever a question comes to agent first of all should take the help of LLM.
Yes.
Hey, LLM, I have got this question. Tell me what to do.
Mm-hmm.
LLM will respond, hey, now use this database tool to fetch the data.
Yeah.
Then Agent will query the tool, use the tool, get the data, and then send it. This is a
Yes.
normal agentic workflow.
Okay, got it.
But in this case, whatever I said, first of all, even before the question is sent to LLM, what we are doing, we know that we are actually using vector database, right? So before even for the first time, my app is talking to LLM. Before that only, we are fetching the query from, we're fetching the relevant documents and then doing this, right? This RAG is actually, I can say, yes, it is not following the agentic flow. You are correct. Yes.
And yeah, and you are just one more thing. So the output from the vector DB, how is it set as a context? I did not follow that final path, right?
Let's assume that we are querying for top 5 documents.
Okay.
So the vector database will return array of 5 documents.
Yes.
Every document will be having text. So what we have to do,
Mm-hmm.
our application has to concatenate all the texts and
Mm-hmm.
then send it as a context.
So when you say it has to send it as a context, means it is just another prompt only, right?
Of course, this is a question answering prompt. My
Huh.
application
Yeah.
is sending a prompt which contains question and the context.
Yeah. So here, uh, what I meant by you know from the context is that whether it will send as a user input or whether it will send it as a system input.
No, no,
In
this
the
is a user. This is a user
okay,
message only. This is a
okay,
user message only. It will
got it,
send
got
this
it.
as a user question. Yes.
Understood. Yeah. Thank you, Shiva.
Thank you. Nrsimha, tell me. You can down the hand, Nikhil. Yeah. Nrsimha, tell me.
Yeah. So one query on the RAG implementation, right? Normally we have this copilot also, right, Shiva? Like therein also we can attach some PDFs and it will, based on the context, it will deploy,
Copilot
right?
also is an agent which is performing RAG in that case.
Okay, okay, okay. So it is inbuilt in Copilot. Okay,
Exactly. Copilot also is an agentic application. Correct.
okay. Thank you.
Yeah. Connor, tell me.
Yeah. So Shiva, I have two questions. First, related to this data which we are giving to the model to generate the embedding. Now, what about data privacy? Like, I cannot give my data to any online model. Like, this is my data, you generate embedding. So the similar way, like in Azure, they have provided OpenAI model in a secure way. So if I need to generate embedding, for that, what should I do? Means there will be some model. Means I cannot go online and then like feed it.
Okay. So there are different kinds of model. Let me answer you. So there are different kinds of embedding models. There are embedding models from OpenAI. As you said, these embedding models are running inside OpenAI environment. If your application is sending the data to OpenAI embedding model, yes, there is some security problem, data problem, right? So what you can do is there are multiple options right now. What you can do is suppose if you are using Azure or Amazon, let us take Azure OpenAI. So in Azure, there is a service called as Azure OpenAI. As I said, within Azure, they have some models deployed. So there is embedding model which is also deployed on Azure OpenAI as a service. So this is your VPC or virtual network. In your virtual network, your application is running. So what your application will be able to make a API call to this model using a secure path. So the data is going between these two networks of these two VPCs. This is global VPC. of Azure, who is Azure is maintaining it, right? So the data will be tunneled from your VPC to this global VPC. So the data is not seen by anyone, and we have to trust on Azure that the data, whatever
Yeah.
we are sending, will not be misused or used. So this is on the
Understood.
Azure. Or another approach is there are models in Hugging Face also. So in Hugging Face, there are some open source models. What you can do, you can download that Hugging Face models on your machine, and you can use it as a local model on your machine. You don't need to send your data. These Hugging Face models can run locally as well.
But your system would require a lot of
Can you
configuration, right, Shiva?
These embedding models are not so big like LLMs. They are not LLMs. These
Okay.
are small models that can run within our systems.
Okay.
Actually, I will
so
show you exactly how to use these Hugging Face models in our code as well. We have a discussion on that.
Okay.
Yeah.
second question is, let's say if we talk about the document example, what
Hmm.
if in that document there is like a it's a PDF document, and
Correct.
in that we have a table. So maybe the 2 page of document is just a table having column name and the uh, uh, some column name and then numerical data into this. So
Whatever.
if we feed, if we feed now, it's an unstructured data. So
Correct.
sorry, structured data. Will it work or it will give some
See,
problem?
again, whether data is in a table or as a pure text, for our use case, we treat it as unstructured data only.
Okay, so it will. That means practically, even if I feed an Excel, just an Excel, which
It's
is
also
having just
it will also
that
treat that as an unstructured data, and we can store it in the vector database, even
embedding.
Excel sheet. Yes, yes.
Understood. Understood. Okay. Thank you.
Now, yeah, next, Ravi, tell me, Ravi. You can down the hand, Konark.
Hi, Siva. So my question is, what I understood is if my information is very huge, for example, in case of this PDF, right, and it is static, then I can store it in vector DB, chunk them, and then based on my query, it is going to send only the specific relevant context to the LLM, right?
Hmm.
Now, if my information is dynamic, right, say it keeps on changing or something like, session information or whatever, which I am collecting from the DB,
Hmm.
which can
Hmm.
vary every day, right? In those kind of scenarios, if I want to send, if that context is also huge, I cannot store it in a RAG, right? In a vector DB and do that, correct?
Correct, correct. So let us, very good question you asked. Let me tell you a solution for this. So what you mean to say is, I have some structured data in my SQL database. Maybe for a simple scenario, let's assume that we are working for an e-commerce website like Amazon and have orders table. Orders will be updated, orders or whatever. This database will change frequently. I have this structured data. Now, what I might want to do is I might want to ask a question related to my database. This is structured data and this can be dynamically changing data. So I want to ask a query related to my database. In this case, we can implement it in different ways. Okay. One way is we can configure this, we can use this as an agentic application. If I ask any query about some information present in database, my agent can be configured with a DB tool, and I can use this LLM as a reasoning engine. I will send this prompt. My agent will send a prompt. Hey, this is a user question. And I have some tools like DB tool, web search tool, etc. LLM will send a response saying, hey, invoke this DB tool to get me the data. DB agent will perform a query and then give the response. Then this is how by using agent, we can use database tool and we can give the answer. This is one approach. But this is not RAG. This is a normal agentic workflow where for the agent will give a database as a tool, and whenever agent sends to LLM will identify, hey, maybe I need to query your database, use your database tool, and give me information. So like that, it can go on. Just like yesterday I have shown you in React prompting technique. We have seen the same thing. How many users are there in my database? I asked, right? So this might be one scenario for dynamically changing data. But there is one more scenario. What if you want to ask a query related to database, but the wording is not same? For example, let's assume that I have a database of products. For every product, there will be a description. For every product, there will be a description. Now I want to search for products. For example, I want to search for eco-friendly product. For example, the query is list all eco-friendly products below 1,000 rupees. This is my query. But in the description in this products table, there might be a product which is eco-friendly, but this term eco-friendly might not be there in the description, right? So do you think when I ask this query, do you think this product will be selected in the select query?
No.
No, right? Because LLM will respond to agent saying, hey, fire this query, select star from product where description like, it might use like eco-friendly and price less than 1,000. So LLM will suggest an SQL query which might use like eco-friendly. But in the description of this particular product, even though it is an eco-friendly product, there is no keyword called as eco-friendly, but there might be some other English word which is having similar meaning like eco-friendly. So in this case, SQL will not help us, right? So what? We might want to do a semantic search on the database. Semantic search. That means we want to find all the products whose description is having 90% similar score for this eco-friendly or whatever, right? So in that case, we need to somehow generate embeddings for the data present in database, right? And then do a similarity search, right? So we will see how this can be done. There is a framework which we are going to discuss called as Llama Index. In Llama Index, what we can do is there are techniques where if you have an SQL database, you can create a index of this database with their embedding so that we can do a similarity search on this database. We can create a dynamic index for this data present in database, and then we'll be able to do a similarity search on that particular index. So there are techniques. To give you a high level overview, we'll see this how to do that on dynamic data. Right now, my RAG is all about static data. This also is RAG. Whatever, if I'm using Llama index, my code, what it will do, it will actually, whenever we get a query, it will dynamically create an index out of your SQL data. Maybe it will fetch related table data, and for that it will create an index dynamically, and then on that index we'll be able to do a semantic search. We'll get that product and then send the description to LLM. We'll get the response. So don't worry, this concept we'll see.
Thank you.
Yeah, Mohan quickly. Yeah, Mohan or Anand. I think some of you, anyone,
Yeah,
can unmute.
Siva, I have see, you said that these documents, we will load the document vector database and then construct the context and sending to the LLM to respond back, right? So how
Mhm.
it is going to cost us, because it has the content may be 5-page document or 1-page document. So as we are using this OpenAI or
Of
any
course, yeah,
LLM
they
model,
will be charged for the tokens, right? So you need to
yeah,
make sure that in your code you retrieve the top five things. Okay, I got your concern. If this, if I get top five, still I am actually loading 5 pages, right?
yeah,
Yeah. So the thing is, let's assume, okay, very good question actually. Let's assume that this is a 1 page of PDF. In 1 page, maybe only these lines are talking about leave policies. Okay, so what my query was, get all the leave policies, right? Only this part in a page is relevant, but this other part is not relevant. If for the entire page, if I create an embedding, for this entire page, if I create an embedding, and if I do a similarity search, I will get the entire document out for my similarity search because this is containing leave policies. So do you think it is good to send the entire document as a context to LLM? Even though my required data is only this part, I'll be sending unnecessary data, right? Which will increase my cost. That is your question, right?
yes, yes,
So that the idea is, again, there are some ideas which we'll be implementing when we go to coding. This is one document, right? Instead of creating embedding for the entire document, we divide this document into smaller chunks.
okay,
So maybe one document might be divided into 5 chunks or whatever, a number of chunks based on the number of tokens, 5 chunks. So for those chunks only embeddings will be created and they will be stored in database. So earlier I told I'll store the entire page document in database. No, in real scenario, we'll be creating even smaller chunks of data and the smaller chunks will be stored. So each chunk you can say maybe containing, let us say, 300 tokens. So each chunk might be relevant, might be having 300 tokens. So the context, whatever you are sending to LLM will become less. Only relevant context will be fetched, and that's how we can save on tokens, right?
okay, thanks,
Yeah,
thanks, sir.
when we actually
So,
see the coding, you will see the chunking part. Yeah.
okay, so one more question I have is, if there is a PDF contains images, we are talking
Mm.
about text. If the PDF contains images, some
Mm.
graphical representation, so how it will help us?
Actually, this RAG is all about text-based similarity search.
Okay,
But there are, by using embedding models, what we can do, we can generate embeddings for images also. We can do a
okay,
similarity search on images as well.
okay. So we need
Right.
to combine both and send to LLM.
But mostly whenever we are talking about this one, right? We'll be talking about text only. This is our LLMs is all about text only. So our
Okay.
RAG scenario does not send images also, because
Mhm.
if my agent sends images in the context, it cannot generate the answer, right? Right now we're talking only about text-based responses.
Okay,
For image search, again, there is a different scenario. For image search, we have to use image-based models.
okay, okay. Thank you.
So Shiva, if we download, right, any of these open source LLMs onto our machines, right, and start using these LLMs, then will there be any cost that gets incurred? No, right?
Zero cost, but you will incur infrastructure cost, right? You have to have a huge infrastructure if you are using it. So that is the cost. If you are downloading on your machine and if you are having good infrastructure, there is zero cost.
Right. Yeah.
Okay. Yeah. Samson, tell me. Or I'll come to you next, Ananda. Yeah, tell me.
Yeah, sure. So you talked about this vector database, right? Like for
Mm.
each model has its own vector database configured. Like how that is connected. I didn't get that part. Like
What
because
model? There are a lot of databases, just like we have multiple SQL database like Oracle, MySQL, SQL Server. There are a lot of vector databases.
no, but
So
how
when
do
you
you
are
tell our model like use this particular database? Is it a configurable thing or
so every database will be having their own API, right?
Mm,
So
mm,
in the API calls, we will pass the embedding model as an argument. Which embedding model? We'll create an object of embedding model and we pass that embedding model. So the API of this database will call that embedding model to generate the embedding, whatever might be, right? For example, let's say this is ChromaDB.
mm,
ChromaDB, let's assume that it is having a method called as save. For example, I'm saying save, I have to pass documents, comma, embedding model object, comma something else. This is an embedding model object, which I'm passing to save function of this ChromaDB API. So this embedding can be either an OpenAI embedding or maybe Hugging Face embedding or whatever might be the object. I'll pass this object. So internally, the save function of Chroma will internally call this embedding to get the actual, call this embedding object to get the value of the embedding, right? So it is independent. Every database API can use any of the embeddings. It is not tied. Got my point?
okay. Okay.
Okay, Anand.
Hi Shiva, I think couple of questions you already answered based on previous questions, and I have few things. One is like in the PDF when you created given the input, like there could be so many context based informations, right? So, but based upon our question, it will create a context because it could be suppose you ask the related leave policy. Based upon that, it create a context is a one
Yeah.
thing, and similarly there could be so many questions. It could be can be framed, right?
Correct.
So that could be combinations could be created dynamically on that.
No. Why question? I didn't get you. See, for this question, whatever question, this is your text, right? This text is talking about leave policies.
Yes.
For this, embedding will be created.
Okay, that's
My
what
app
the
will create an embedding,
embeddeds are
and then
created
we'll
dynamically based upon your question.
exactly. Yes, yes. Dynamically, my app has to create an embedding, and then using this embedding, a similarity search has to be done.
Okay. Okay. Second thing is okay. That means like suppose based on if you are now you ask about leave policy, maybe you ask about some other related to the uh,
Attendance policy.
some other attendance policy, something and information in detail or some other thing. Based upon that question, it create a context categories
It will
and a
for
dynamically.
that given question again it will generate an embedding, and then using this embedding it will do a similarity search, get
Okay.
relevant documents, and then
Okay. So,
create a context.
okay. All of them is run in a dynamically on that way, not in the
Dynamic.
static. Okay. Okay. And one more thing is like now you're given as a one PDF information and trying to generate it, right? What
In
could be
vector database, I could ingest 1,000 PDFs.
so you can generate the questions based upon the combination of PDFs, right?
Whatever. For me, once the data is ingested into vector database, I don't bother about which PDF it is. There is a lot of data in the vector database. You can search.
Understood. Yeah, thank you. I think there is one more like suppose in your PDFs it could be like state diagrams, so like as a bank statements. I have multiple banks accounts information, and my expecting the summarization of all the bank related information.
Yeah, it can do. It can do because that statement also is a text, right? It can
Yeah.
understand this statement is talking about what all or this. It can do that. Correct. RAG
Okay.
can do that. It can find the documents. What document is talking about the statement, it can find, it can send that information to LLM. LLM can extract the information from your bank statement.
Okay. And thank you. Thanks, Shiva.
Yeah, Shiva. Somehow I'm not able to raise the hand. Some it is giving me an error. So I just have a question on the same follow up, like just before the question. So RAG basically we use it whenever the data been changing dynamically. I mean to say RAG like more frequent data. Why? Because we cannot really train every time the models. It is expensive. So that's where
Correct.
RAG is one of the best use case, right?
Correct.
So on the
Correct.
lines, for example, I have two questions. One is. Here in this case it is just a PDF, but in real time scenario or enterprise solution it can be either a other database or it can be some Confluence page or it can be some a drive, maybe for example a Google Drive, or it can be any data source,
Anything.
right? It can be any data
anything,
source.
anything.
Got it.
So
And second
you might
thing,
want to do a similarity search on those databases or Confluence or whatever. So there are libraries like Llama Index where we can actually index any source, whether it is Confluence or GitHub or database or anything. Llama Index gives us a various ways to dynamically create indexes for
okay,
your unstructured data or structured data, and then query on that indexes. There are
got
techniques in Llama Index which we are going to see.
got it. So in that case also these indexes or these embeddings will be saved in some other vector DB again, right?
And
Or
again, no. These are again, there are different scenarios. Based on the scenarios, we have to take a decision. So these indexes can be dynamically created in memory, or
okay,
maybe there are techniques like if you have a huge database where this database changes very less frequently. That means maybe that database will change every 1 week. What we can do, we can create an index of the entire database and store it in a vector database. If they
okay,
are having static data, that means every week, if you feel like the data will change, then that can be stored in vector database, and then this vector database can be queried. But if you're having frequently changed data, then this will not work because you have to re-index the vector database every time. So in that case, in-memory indexes can be created. There are techniques which we'll be discussing in Llama Index.
got it, got it. Thanks, Shivan. Second thing is, in case, let's say maybe a PDF or maybe another source, let's assume I'm just limiting my question to the vector database. If I want to add new embeddings to the vector database, but I don't want to run on complete data again. For example, there is some changes to my data source, okay, and some updates has been done. Okay, so or maybe some additions to the
So
existing
you
data
have,
has been
see,
done.
who is writing the code to store the data in vector database? You are writing the code to store the data, whether it is whatever data. You have
Right.
to decide what data to store. So
Mm,
let's assume that you are having 1,000 rows in your database table. For example,
right.
you have 100 more rows. You have to fetch those 100 rows and then uh, create embeddings and store those new rows only into vector database. It's your code which has to decide what data has
Exactly.
to be indexed.
Right.
Your code has to take care.
Exactly. So I'm looking for, is there anything like a automated approach, like which will be identifies the updates and then update my vector store.
There
That's
are
what I'm
libraries. Yes, there are.
okay. Yeah. Thanks, Shiva.
Okay. So I think, shall I go ahead or still few more questions are there? Yeah, no problem. We'll take the questions. Questions are always good. Yeah, please ask. Anybody? Maybe
Yeah.
Ramchandra. I think you didn't get a chance from a lot of time. Ramchandra, you can ask.
Sure. Thank you. If I'm understanding it, as far as the vector database is concerned, if anyone is having a vector database, so we have to be taking care of inputting the data. That means that we have to be taking care of embedding the data.
Storing the data.
So that yes, it's just storing the data, or also we have to be making sure that the data that is stored is also embedded.
Actually, once we see the code, how to do it, there are methods like, for example, load. There's a function called as load. This load will be passing the documents array and embedding object. So the load method of the database API, if I just pass embedding, it will take care of generating the embedding using this embedding object or model and then store it.
So basically, the service whichever we are actually calling to this embedding database will take care of
Creating the
taking the
embedding and
request.
storing it.
Okay. And storing it, and when it wants to be retrieved it, I think it'll also make use of that embedding to retrieve the data,
Exactly.
create that documents, which is, I mean, create the similar documents, maybe 3 or 4, and
Yes.
then give the output as the document so that the document can be, you know, lined into LLM for the result.
Exactly.
Okay. One last question. So if I mean this embedding database, do we use for structured data? Like if I'm using it for a normal database, like an Oracle database, Is there a need of, I don't think there's a need of using an embedding database for that, right? Because we can use an SQL query to get that data.
No, that's the use case I told you, right? Suppose if you're having a products table and products table is having a description of each product. Now I want to query for eco-friendly products. But in the description of the product, this exact keyword eco-friendly is not there. But there is another word which is similar to eco-friendly. So if I use an SQL, I'll be using
Okay,
something like it. This
got
this row will not be fetched by writing an SQL query. In this case, we want to do a semantic search on a structured data as well. There are scenarios. So we need to create indexes or we need to store them in vector databases to do all that. There are scenarios which we'll be discussing later.
got it. Thanks,
Yeah.
Shiva.
So Shiva, my same vector DB can have two documents which are embedded in OpenAI and another 5 documents which are embedded in say LLM, some other embeddings, right? That is possible, correct?
No. Okay, well, let me tell you. So in vector databases, see, let's assume, for example, I have MySQL server installed, MySQL or Oracle server installed. In one server, can I have 2 databases, 10 databases?
Different databases possible, right?
Yes. Yes,
Yeah,
I can have multiple databases on one server, right?
correct.
Similarly, on vector database server, you can create something called as collections.
Oh, okay.
Okay. So you can have collection 1, collection 2, collection 3. For one collection, one embedding model. Maybe for collection 1, you can use embedding model 1. For collection 2, you can use embedding model 2. Whenever you're querying this collection, you have to use same model. Whatever you use for say storing, you have to use same model while retrieving also. Otherwise, that search will not happen properly.
Okay, understood. And this metadata, who is creating the metadata? Is it the is it the application developer or this tool
Yeah,
itself?
whenever we are writing the code to save, right, there we can write the logic, or by default, these APIs will generate the default metadata.
Okay.
Suppose if I am storing from PDF, the metadata will contain page number, PDF name, a file location, etc. Whatever. That will be automatically done by the libraries.
Thank you.
Yeah, quickly, Nrsimha, tell me.
Yeah, Shiva, actually, there is something called RAG fusion, right, wherein we can give multiple variations of the query, right, for a better searching.
Yeah, those techniques also we will see. How to retrieve, there is something called as multi-query retriever. So if you give a single prompt, so as a user, you might not be giving a correct keywords in your query. If you don't give correct queries, if the user doesn't use correct keywords, retrieval also will not be so good, right?
Correct.
So there are techniques where for the given query, by using the help of LLM, I can generate 3 variations of same query. The same query, how a user can ask in 3 variations or 5 variations. And I can do a semantic search using all the 3 variations and I can retrieve the context. Those techniques are there.
Okay, Shiva. Thank you.
Yeah. Yes, Samson.
No,
You
I
raised it.
was not able to lower my hand.
Okay, Connor, finally, can you tell me your query?
Yeah. So as we can see, like this is getting more complex when we have diverse set of data in real time scenario. We have images, maybe different data sources, which is are like
This
two
is
three
only
different.
for text-based similarity search. What
Yeah,
I
I got it.
discussed. Yeah.
But like we have the, let's say, images, audio files, maybe some video file, and then obviously we'll convert video to text. But what I am saying, like we might in real scenario we will be having a diverse set of data sources, and then we need to do a similarity search on that or something. So instead of because in our organization they use the Azure Open AI search, means where all the data we have feed to that search model using exposing using views, because we have the SQL only in terms of data sources. So all these will be in the view we have exposed, and then now search is working, and it's a semantic search. But so
There
we need to
also
build.
Azure AI search is using same techniques.
Yeah. So that's why I'm asking. So in a general scenario where we have this thing, so if organization like prefer okay build it from scratch like as the we are like use the llama index and all, or they are saying okay this is the service which can take the different data sources, maybe some Azure service or AWS service. You feed the data in a good way, and then it will like generate it for you, and you can build agent or using that service. What is the like I understood like for learning purpose we are doing, we should at least know, but what is the like approach today? That is the question.
So always, if you want ready-made services, cloud is always a preferred option, but there is a price you pay to that service, right? If you are using Azure AI search, you are paying a price to that. So Azure AI search also is not doing some very complicated. It is also internally using its own vector database, not
Yeah.
this Chroma. So it is having its own vector database and it's doing the same. But your work will be very simple. Like you just have to go through the UI, upload the documents, or you can just configure something which automatically fetches. Your work is easy. But finally, at the end of the day, concept are same. Okay.
So
Yeah.
means right now organizations are saying no, build our own or use those services. That is the question. Means
Better to go for cloud if you can afford it. That's it. Simple.
okay,
It's
understood.
all about affordability cost. So ready-made solutions are already there on cloud. If you can afford it, instead of you building it on premise, you can go for a cloud solution. It is ready-made. The only thing is whether you want to whether that can be affordable or not, whether you want to spend on it or not. And this is all not so complex. It is a simple thing. Even there also we have to ingest the data. Only ingestion is one thing which you are saving, and that can be very simple also through code. I will talk about Azure AI vector search also. That is there in our topics. You will understand at that point, right? We can compare at that point. Okay, let me go ahead. Actually, we are getting stuck at this point, but I appreciate all of your questions. I think the questions are also very important in the training. Everybody is getting from different perspectives. Always, it is good to have more questions. Yeah. So let me proceed so that I can just complete whatever I want right now. So we understood clearly about RAG, is it? How it works. Now I wanted to quickly show you a simple program, how I can use OpenAI embeddings to generate embedding for a given text. Okay. So quickly, last program, another 5 minutes, I will show you how to actually use OpenAI embeddings to generate embeddings. So I'll just write embeddings demo.ipynb. Okay. So what I will do is right now, let me connect to the kernel. I'll connect to this kernel from .env, import load.env. I'll just call load env, which will load the env file. Yep. So then I'll just copy paste to save some time. I will just use importing OpenAI from OpenAI. Then I want to create an object of OpenAI. Yeah. And then I want to get embeddings and get similarity score for these two texts, sunny day and bright day. Okay, let me just run this. Fine. How to generate the embeddings? Very simple. Actually, I said that there is a model called as text embedding ADA model in OpenAI. I will just go to playground, openai.com, docs, models. Here, if you see, there will be embedding models. Yes, these are the embedding models from OpenAI. I want to use this text embedding 3 small. How to do it? Very simple. Client dot embeddings dot create, and I have to pass input is equals to text1 and model is equals to this model text embedding ADA002. Text embedding ADA002. This is a model which I am using. Any model I can use. That's all. This will give me the response. Let me just print the response, whatever I get. Yep, the response is nothing but an object of create embedding response. Actually, this embeddings.create will make an API call, send this text sunny day, and tell, okay, this is a model to which I want to, this is a model which I want to use. So I got a response. Now let us try to get the response. This is an object of create embeddings response. Dot data. Data is an embedding array. Data of 0 will give me the first element, and that is having embedding. So if I just run this, see, I got an array of numbers. This array size. Let us see what is the size of this. I will just see the size of this array. 1536. The array size is 1536. This OpenAI embedding model is generating an array of size 1536. It is so big array.
Just
right?
for 2 words, this many. Just
Yeah,
for
whether
2 words.
whether this
Just
is
for
one
2 words.
whatever, whether it is one word or one character or a big sentence, it will generate such embed. So constant size 1536.
Oh, it's always a constant, huh? Okay, okay.
It's always constant.
Okay.
Yeah. So now I want to write a function which can actually return the embeddings. Let me just show you the similarity score, how I can get. I want to show you how to generate the similarity score. This is a function where I'm using client.embeddings.create. I'm passing the input and this model and returning just like here. If I call this function and pass the text, it will give me the embedding. Okay. Now, once we have embeddings, we have to calculate the cosine similarity, right? Of two vectors. So what I will do is I will get embeddings for both this text, text1 and text2. I want to get the embedding. So what I can do is get embedding. I'm passing text1, text2. I'll get two embeddings. Then I want to find a cosine similarity. Cosine similarity means, okay, let me tell you, I have two vectors, vector A, vector B. I want to find cos of A comma B, cosine value between A and B. If you know the formula, it is dot product of A and B divided by magnitude of A, magnitude of B. This is a formula, if you remember in your 11th and 12th classes, you might have used. Right, this is a formula to find the cosine value. So what I will do is I will actually use NumPy to actually get that value. So I'm writing a simple function, cosine similarity. If I pass two vectors, this is calculating np dot dot. It will calculate the dot product, and this will give the magnitude of this vector and magnitude. So this is a formula to actually get the cosine similarity. Right now, if I run this, is a function which I define. Okay, if I call this, I'll get the similarity. Let me print the similarity. What is the similarity? Yes, these two sentences are 89% similar. I got the similarity score based on embeddings. This is just to give you an idea about how to generate an embedding by using OpenAI embedding model. And once we have embeddings, those are nothing but vectors. How to actually calculate the cosine similarity? This is just to give you an idea. Mostly we will not be writing this because this will be taken care by vector databases most of the times. But this is how you can visualize. Okay.
Okay, so this is just an embedding technique. Like right now, we are not storing anything to database.
No, just
that will
finding
be coming. Okay.
What is the similarity score. That's all.
Okay. Okay. But
Storing them in vector database, we'll see later.
sure.
Okay, that's all I think for today. We will start freshly with LangChain introduction and we'll continue with LangChain tomorrow.
Shiva, one query here. So
now you
far
can
we
ask
see,
any question.
yeah, it's part of OpenAI, right? I mean, most of like OpenAI, like there are any other competitors which we have in demand because most of we're talking on OpenAI, right?
Lot of things, lot of
Okay.
embeddings are there. For example, you have Hugging Face models. In Hugging Face website, there are a lot of embedding models, open source embedding models. I will show you later how to use those open source Hugging Face models. We will see lot of models are there. And for every database, there is their own embedding model. For example, if I'm using Pinecone as a vector database, Pinecone has its own embedding model.
Right.
Suppose if I'm using PG vector as my vector database, PG vector embedding model is there. Every database also has their own embedding models.
Okay, like how AWS, Google, and Azure is in demand.
Everybody
Similarly,
Azure has their own embedding models.
Embedding models. Okay.
Yeah. Any other queries?
So basically, both can be treated as independently. I can use any embedded model, whether it is from OpenAI or from any open source, and I can get the similarity context and then pass that to any
vector
LLM.
database. Any vector database. Any vector database can be used with any model.
Right. Yeah.
Okay. Okay, then I will.